Spring One tour and have visited us in the past at a city near you. And clearly travel is it's not that easy right now, and that's okay. It happens. We're taking care of it. We're being healthy. We're staying safe. And so we're bringing the tour to you, and this is awesome. We've got some of our tour favorites kicking us off. Nate Schutta and Jakub Pilimon joining us today to talk cloud native architecture. It's going to be incredible. So thank you so much for joining us. Last I checked, we had over 1,200 attendees that registered. So to all of you that are joining it, that's amazing. And congratulations. Thank you for showing up to help, be a part of this great spring community, as well as, educate yourself on great ways to get enterprise software better and make your lives hopefully a little bit easier in this already difficult world that we live in. Anyway, if you hear any noises on the side, I've got one of my coworkers, Schutta. She's a 10-year-old English bulldog, and she makes a lot of noises. So if you hear anything, I apologize. But coworkers, am I right? I've got a couple things I want to go over before we get over to Nate and Jakub. First of all, Spring One, our big spring conference that we hold every year, Spring One platform, as it's been called in the years past, that is going virtual as well. That's happening September 2nd and 3rd, and this year, of course. And the thing that you need to know specifically is if you have a desire to present, the call for papers ends today. So go to spring1.io. And there's you can register to attend, but also there's a submit a talk button, and that button will go away today. So if you don't do it, then you can still attend, but you can't submit your talk. So if you have a desire to talk, go to spring1.io, submit your talk, and definitely register for this incredible 2-day event, all things spring. So many people in the spring community are going to be presenting. Of course, your Josh Longs and your Mark Hecklers and your Spencer Gibbs. Nate, Jakub, have you submitted a talk? Are you...
I will do that first thing after the talk. I will submit. I promise.
Okay, good, because that's the day. You have to do it today. And so, anyway, yes. Then we're going to move on to, we have, of course, this is the inaugural Spring One tour, but the third Wednesday and Thursday of every month, we're now dedicating to Spring One tour. So we have some incredible lineups coming up. June 24th and 25th, we're doing CI/CD stuff. July 22nd, 23rd, we're doing spring tips, reactive spring. And then August 19th and 20th, we're doing microservices.next with Spring. So make sure you register for those events as well. And that's at springonetour.io. Also, a very exciting thing that just launched like a week ago at VMware. It's the Tanzu developer portal area. And so basically tanzu.vmware.com/developer. There's blogs and community pages and ways for you to interact with the different enterprise level developer software happenings with VMware. And so it's all very exciting and new. So make sure you head over there again, tanzu.vmware.com/developer, join the community, start engaging with other people again to make this enterprise software game that much better for all of us. And last but not least, if you're working with anything with Kubernetes, that's the hot buzzword bingo word these days, Kubernetes. TGI, thank God it's Kubernetes, has a YouTube page. They have 118 episodes so far. So you have a lot of homework to do by next month. I hope you have all will watch it by then. No, but anyway, lots and lots of amazing Kubernetes topics to go through. So head on over to YouTube, type in TGIK or TGI Kubernetes, and you will find so much, a plethora, if I can say that, of Kubernetes video content. And also on Tuesdays, we host another show, myself, Paul Charkovsky, and Tiffany Jernigan. It's called Tanzu Tuesdays, and it's on twitch.tv/makejar.not.war. And we host, all things kind of developer-based. We've got Tiffany Jernigan going to talk CF, Cloud Foundry for Kubernetes, CF K8, Kates. Sorry, I'm kind of decoding it as I'm saying it to you. But anyway, Cloud Foundry for Kubernetes, that'll be happening Tuesday. It's 1 p.m. Pacific. It's live, but then we also post it on YouTube. So those are my updates. Wow, I'm gonna have to take a sip of water after that. All right, let's bring back in Nate and Jakub and talk to them. How are you? Good morning, gentlemen. Thank you for joining us.
Thank you, Bob. Thanks to all of you for being here. I think this is, for those of you still observing days, is Wednesday. So thank you for taking some time out of your Wednesday to join us. Good morning, good afternoon, good evening, depending on your preferred time zone here.
That's right.
It's good to see you too, my friend.
You're in the Minnesota area. So
I am.
You're 2 hours ahead. So you're almost in the afternoon. It's almost
practically lunchtime.
Yeah. Or in the pandemic time frame, it's pre-lunch, which will be followed by lunch, and then lunch dessert. So
right, and then staring out the window while eating. Yes.
And then Jakub, what time is it for you, my friend?
Hello, everyone. In my case, it's a good afternoon, I would say, or good evening. It's 6 p.m. Is it evening or afternoon? I have no idea.
Boy, the lines are blurry there between an afternoon and an evening. I think that's your call.
It's still sunny. I think it's afternoon.
Oh, yeah, anyway, let's go with afternoon.
So yes, you're coming live from Poland, which is incredible, Warsaw. And so we're happy to have you join us. And yeah, when does the sun set there? I think that's another time to know if it's good evening or good night.
I think around 9, something like that. No, it keeps changing every day, from what I know.
This crazy world we live in.
The days just keep getting longer for another month or so.
It happens. All right. Well, I have spoken a good amount, and I know everyone is of course here to hear me, but really they're here to see you. So let's get on to you, Nate, and let's get on this cloud native architecture stuff. I can't wait to hear more about it. Take it away, my friend.
All right, fantastic. Thank you, Bob, and again, thanks to all of you for taking some time out to join us here. So what we're going to do here is I'll do some lecture for a bit, kind of do some 12 factory stuff, and then Jakub and I'll do a little architectural discussion after the break. But this is just a chance for us to do some level setting, because one of the things that we discover is there's a lot of fear, uncertainty, and doubt. There's a lot of confusion. And so just make sure we're all on the same page about what we're even talking about in this cloud native world. There's a lot of options here, and when we talk to folks, some people will say, oh, well, the cloud means microservices, and others say, no, we're doing modular monoliths. Of course, containers and Kubernetes are very popular. And then you always have the person who's like, oh, forget all that. I'm just going to write a function, do this serverless thing, because I don't even want to manage that at all. I want that to all just be done for me. And so there's lots of talks about functions as a service. I'm actually convinced that we're at that point in software where you can literally put any word in front of as a service and it works out. It's probably a startup that's in its first round funding. And we're also in a situation where some people are trying to spread things across multiple providers, and then someone like me shows up and says, hey, 12 factors, and you're like, well, wait, why 12? Why not 11? Why not 13? And what does that mean for my application? Am I 12 factor compliant or not? And most importantly, for a lot of us, we've got hundreds, maybe thousands of applications in our portfolio that were designed before anybody had even thought of this idea of 12 factors. So what do I do with all those apps? I can't just throw them away and start over. So how do I, as a busy developer, make sense of all this? So let's start by just kind of level setting on what we even mean by cloud native. And of course, there's always a tweet. This is one of my favorites. Ask your doctor if cloud native is right for you. It's always a good place to start. Just check with your physician before you go down this path of cloud native applications. To be real succinct, it's just taking advantage of what the cloud gives us. And so it's about how we create apps. It's about how we deploy applications, because we get some very interesting capabilities out of cloud. We can scale up, we can scale down, we can do this all on demand. That's a huge win for us, especially in our traditional single digit server utilization world. We have limitless compute, at least theoretically, although it really isn't limitless. I mean, there's still computers there, even if we're not the ones that have to manage this. A friend of mine told me that the company he was working with, their data scientists had gotten very excited about the cloud, and they were really interested in all the things they could do. And they spun something up overnight and ran it. And the next day, their cloud provider called them and said, are you guys ever planning on doing that again? Because if you do, we're going to need to buy more computers for that data center, because you literally took all of our existing compute. And I think shortly thereafter, their CFO had a conversation with him about their cloud bill. But it's important to realize there's a huge asterisk at the end of that limitless compute, and that's the additional fees may apply. And one of the things that becomes obvious when you start playing in this space is those fees can be rather opaque and hard to understand. This tweet really stood out to me when I ran into it. It said, I've been paying Amazon 80 cents every month. And so I spent an hour trying to figure out what did I forget to turn off. And I thought I had everything. Well, now I'm getting a bill for 23 cents. There's a lot to be said for that. It's very hard sometimes to know well, it's so easy to spin something up. You don't even realize, you're doing it, what services you're tapping into. And I love this one too. I was looking at the simple cost calculator, and it turns out it's maybe not so simple. Where's the complex calculator? How many instances of EC2 do I need to actually run this thing? And they're not too far off. I mean, if you've ever played with it, you can see there's a lot of boxes you have to check and fill in, and I mean, it tries to give you a sense of what it's going to cost. So I see why there's some complexity there, but it isn't as simple as maybe we'd like it to be. This is another important thing to remember. It's so easy to turn things on. You don't even realize you're doing it. And so I love this. We spent 2 hours going in and turning off the things we weren't using, and it dropped our spend considerably. There actually are people who, I guess the right term would be forensic accountants. They go around and help you digest your bill and then figure out how to trim it. Now, this is more than just an architectural pattern. It's this interesting combination of practices and techniques and technologies. There's going to be some amount of agile development. We can argue about what that means. There's going to be some continuous delivery, some site reliability engineering. There's going to be a heavy dose of automation. You can't do this at scale if it's all by hand, if it's all right click deploy type situations. You're just never going to be able to do this at the scale that we need to today. There's going to be some containers, there might be some microservices, might be some functions. It's important to realize that this has a pretty heavy effect on our culture as well. And I do think this gets short shrift, unfortunately. I'm a technologist. I've been in this my whole career. I love toys like this. I love playing with computers, and I think I've got a great job. I get to play with technology day in, day out. And we forget about the impact that this has on our culture and just how important it is to look at that and address that. These are big shifts in our organizations, and we need to make sure that we're taking that into account as well. We don't just get too infatuated by the shiny new toy we have. It's going to be some DevOps, although again, some people refer to that more as SRE these days. And what's fascinating to me is to see this big shift in infrastructure from when I first started in software. I've been doing this just over 20 years. And when I first got into this industry, as we started to build web apps, all of our servers were homegrown. I mean, we literally ordered the parts, pushed the RAM chips in and tried not to break them, and then we built these things by hand. They were this bespoke artisanal kind of thing. And while I love a beautiful cup of coffee that's hand, made by this barista, it's not so great for my infrastructure. And after spending all this time crafting these things and giving them pithy names, I worked at one company where I think our servers were named after Simpsons characters, and some people named them after Marvel characters, and we all came up with crafty names. But we started treating these things like pets. They were part of the family, and I know Bob mentioned this at the top of the show here. These are my pets. They're actually not bothering me today. Usually, as soon as I get on a call, they're all over me trying to see what's going on. But this is Han and Chewie. That's Han in the front, Chewie in the back. Chewie's actually kind of a scaredy cat. It's kind of weird how that works. But these two little critters are members of the family, and if either of them were to have so much as a sniffle, I'm sure that my wife and my son would compel me to spend vast amounts of money trying to make them happy and healthy. And that's what we used to do with our infrastructure. We took all this time to build them, all this time to get them up and running, and we did whatever it took to keep them happy and healthy. And of course, in this era in software, our servers were this very heavily constrained resource. They were a very expensive resource. There were these corporations worth billions of dollars that sold us hardware. And so it was incumbent upon us as developers, as architects, to get our money's worth out of that, to make sure that we were really getting that return on investment. And that's where this app server concept came into the picture, because it was in our best interest to put as many apps as possible on one box to, again, make the bean counters happy. Now, while that certainly made the accountants and the CFO pleased, it had some unintended side effects for us as development teams because, oh, hey, look, we have shared resources. And now that I have shared resources, it turns out that one application can make a mistake that takes down my application. This actually happened to me multiple times in my career, but I remember coming into the office on a random Monday morning. One of my applications was down, so I started digging into it and realized that over the weekend, someone had put a MIME type change in on our server. And it turns out that of the 10 apps running on that box, 9 were not functioning that particular Monday morning because of that MIME type change. The one that wanted the MIME type change was just fine, of course. Now, I have no idea why this wasn't caught in a lower region or why that even caused these apps to go down, but this was a fairly common experience for many of us. Of course, you probably remember how much fun it was to coordinate changes during this era in software. You'd be trying to get to the next version of Java or the next version of a framework or something like that. And your infrastructure people came back and said, no, I'm sorry, you can't have nice things because we're waiting for these other applications. And it turns out the Wombat app is our long pole and they're not ready. You're going to have to stay on Java 1.4 for forever, basically. And having been a part of several of these currency projects, they weren't a lot of fun. There were these 18-month sort of slogs of freezes and testing and frustration and, why doesn't this work? And, oh, we made this small change and now the fonts look weird. And it just was a real pain. It was not a lot of fun. And of course, our customers didn't enjoy that at all. And this is frankly why an awful lot of organizations said, currency, it's just not worth it. We're going to kick the can down the street and we're going to assume someone else is going to solve this problem in the future. I'm going to move on to something more interesting that might get me a raise, a promotion, a bonus. And what this era reminded me of is that great Yoda quote, fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. And I had no idea, but for much of my career, we were actually practicing Yoda ops. That's what we were doing ultimately. And during this era of software, we were literally moving code from one server to another, from one instance of an app server running on one piece of hardware to another instance of allegedly the same app server on a different piece of hardware. And we're all just like, fingers crossed, hope it works. But it didn't always. And it was very common to have that wonderful experience where, well, it worked in dev, but not in test, or it worked in test, but not in QA, or whatever it happens to be. And you sit there and go, why? Why am I dealing with this? It worked here. Why didn't it work there? Because the environments, they're supposed to be the same. They're supposed to be identical. And so you start pounding your head against the table, digging into it, trying to figure out what happened, what caused this problem. This happened to me on one of my projects, and we started digging into it. And after about 2 weeks of grinding, what we ended up ultimately discovering as the root cause, the patches were applied in a different order. So yes, the servers were at the same patch level of everything, but they put the patches on in different orders, and thus it didn't work in one region and it did in the other. And to be fair, this is when you take a step back and you reflect upon your life choices and you think, is it time for me to change my career? How did I get here? There's got to be a better way to make a living. And luckily for us, things have started to change. Things have evolved. That's pretty normal in our line of work. And we're at this point now where servers are frankly a commodity. They're no longer this proprietary thing. We're using off-the-shelf components and off-the-shelf operating systems. And so we're seeing a big change in sort of the financial dynamics. Which of course leads me to this tweet. This is another one of my personal favorites. Dad, what are clouds made of? Linux servers, mostly, son. I've reflected a bit on this. Yesterday was my birthday. Thank you. And I've reflected a bit on this, how different raising a child is today and beyond just the pandemic versus when I was a kid. And I think about these kinds of questions that my son would ask me that, if I were to ask my father that, it would be like, he'd make up an answer or, well, I don't know, I guess we'll have to look it up in the encyclopedia. And I think about today, the kinds of questions my son asked me, and now he just says, "Hey, Dad, ask Siri, what XYZ is." And it's like, yeah, you kind of get used to being able to do that, right? So as we've seen this shift, not surprisingly, prices have dropped, and we started to realize that it turns out servers aren't really the constraining factor anymore. It's actually us. We're the expensive piece of the equation. Frankly, we've always kind of been the expensive piece of the equation. But as things like Heroku and AWS and App Engine and Cloud Foundry and Azure and whatnot have become commonplace, we're starting to recognize that shared servers are really a liability, and having this ability to just spin up what I need and have everything contained turns out to be very, very powerful. And so now, instead of treating our servers like a precious pet, a member of the family, we kind of want to treat them like cows. And when they get sick, we should just get a new instance. And I grew up on a hobby farm, so our cows are really more pets than anything else. Although we did name some of them as a reminder of what was eventually going to happen to them, one fall. But for most cattle operations, cows don't get names. They get a number. And if number 15 here gets a little sick, we're probably just going to spin up a new instance of 15. Sorry, 15. And so now we've got these new abstractions that we get to leverage. And so we have containers and platforms that change our approach. And instead of having this code that we move from one instance of an app server to another, we say, you know what, just put everything together, put it all in a box. I'm going to move that box from one spot to another. So in this environment, if it works in dev, well, it's going to work in test because I'm testing the exact same thing. A whole class of problems just goes away. This is a huge win for us. We've never wanted extra variables in the equation. We've never wanted infrastructure that was bespoke and artisanal. So now in this environment, hey, if you need a new library, great, go ahead. You're not going to impact somebody else because you're all isolated. So if you want to rev to the next version, you want to get on that dot release, go ahead. You're only impacting yourself. You're not impacting other applications that happen to be on that shared hardware. Now, I have had some prod ops people push back on me on this. In fact, I very distinctly remember several years ago now, but one of our prod ops people was a little upset with me when I made this comment. He said, "Well, Nate, that's going to be really resource intensive, and you're going to have these libraries are going to be duplicated across multiple servers, and that's just such a waste." And I thought, okay, you know what? Here's a few dollars I have in my wallet that should cover the cost. And then, of course, if you just remove the fact that I don't have to chase down these weird issues, I don't have to be stuck lowest common denominator just because the Wombat app's not ready. I can go ahead and migrate. That's a huge, huge win. There's a lot of value in that for us. So it absolutely moves the value line. This is huge. It gets us out of the business of undifferentiated heavy lifting, which takes me to this. This is one of my favorite slides ever. This is my old boss, Andrew Clay Schaefer. "Good job configuring servers this year," said no CEO ever. Now, to be clear, it's important work. It has to be done. We can't afford to let things just sort of stagnate on old versions. We have to do that work, but it's not really seen as high value. It's not the kind of thing that we want to have to spend days and days and days on. We really rather have someone else deal with that. And so for us as developers, as architects, it really changes our approach to development. We can fully embrace that always be changing mindset. We can afford to be more aggressive in how we migrate things. We can run those experiments. We can do those A/B tests. We can be far more responsive to our business partners. And this is hugely important because we've seen this massive shift. When I first started in IT, I think the most common sort of estimate for us to give on a project was 18 months. How long will that take? Oh, it'll take 18 months. And that kind of worked, I guess, for some definition of worked. But that's not the world we live in today. Today, we need to deliver in days or weeks, certainly not months and years. That's just not going to work. Our competitors are going to beat us to the punch if it takes us that long. And that leads me to this experience I had at Spring One a few years ago. A gentleman from Scotiabank got up and talked about their journey from the traditional sort of 4 releases a year to thousands of releases. Now, that didn't happen overnight. There's an awful lot of engineering effort and discipline that goes into this. There were hiccups along the way. But the message for me is that if a almost 100-year-old bank can make this transition, well, so can you. And what was really fascinating for me is several of my friends from my former job were at this event, and we were chatting in the hallway one day, and they said, "Oh, Nate, we're never going to be able to get to that. We can't do that." And I said, "Guys, of course you can. I mean, I know I've been there, I've done that, but if a bank can make that transition, you can too." And you have to. You can't afford to just do things the way we used to. That's how we've always done it. It's the most dangerous phrase you hear in an organization today. We have to banish that from our repertoire because the reality now is speed matters. We have to move quickly because disruption is impacting every single business. There's no industry that's immune from this. If you're a grocery store, you might have thought a while ago, we don't have to worry about any of this. And then all of a sudden, Amazon buys Whole Foods, and now you can order your groceries very easily online. And it's like, oh, wait a minute, we might want to rethink this a little bit. When I first got into IT, my very first job out of college, the CIO came and gave us this presentation about the business and yada yada. And one of the comments he made is, "Hey, we're just a cost center. We're here to support the business. The business is this. We're just here to help." And I thought, what a change in the attitude, because I was at a client a couple years ago, and their CIO got up and made a completely different conversation. He said, "Folks, we're a technology company that happens to be in retail. That's the way we have to approach this." And I thought, how powerful, and what a huge shift in a course of a couple of decades. But that's the reality we all face, whether it's convenient or not. A lot of insurance companies are looking around going, "Hey, Google's actually a pretty strong competitor of ours. They're really good at managing information. That's kind of what we do too, and play the float on our investments." But whether it's convenient or not, we're all technology companies today. And this is becoming hugely important. We have to be responsive. We have to be able to help our business partners compete in this very aggressive era we live in. Now that takes us to the 12 factors, otherwise known as the 12-factor app. And this is just a set of characteristics that successful apps share, at least according to Heroku. Now, I would argue these are pretty good characteristics, regardless of what your ultimate deployment platform is. I don't think there's too many things in here I would nitpick about. We start with, version control. That's not controversial. I hope multiple deploys out of there. You need to explicitly define your dependencies. You want to separate configuration out from the code. You want to treat backing services as attached resources, and you want to have this build, release, run lifecycle. We want to be stateless as much as possible. State sucks. There's no getting around it. It's hard. If you don't think managing state is hard, why does rebooting fix 80% of our problems? Said one of my friends over Twitter last year. We want to export services via port bindings. We scale via process scale horizontally instead of having bigger hardware. We need to start up fast, shut down fast. We want dev prod parity. I don't think I've ever wanted these to not be true, right? When have you ever wanted dev and prod to be different, just to add extra fun and excitement to your day? Probably not. We need to treat logs as an event stream. That's a little bit of a shift for people, but it's not the hardest thing we have to deal with. And then we want our admin tasks to run as a one-off in the same environment. So let's dive into this a little more deeply. So one code base in version control, multiple deploys. That's not controversial, right? Everybody's using version control. You're probably using Git, or maybe you're using Git, or perhaps you're using Git. Now, this hasn't always been the case for us. I remember many years ago, one of my friends pinged me one day at work. He said, "Hey, can you help me? I'm having a problem on my project." And I said, "Sure, no problem. Send me the link to your repo and I'll take a look at your code." And he said, "What do you mean the link to the repo?" I said, "Well, your Subversion repo, just send me a link." And he said, "Oh, no, we're not using Subversion." I said, "Oh, okay. Well, are you guys still on ClearCase then?" He's like, "No, we're not using ClearCase either." I'm like, "Well, if you're not using that, what else do we have here?" And he said, "Oh, no, we just keep all the code out on the LAN. And every so often I just make a duplication of the folder. And, we email each other files. It works pretty well." And that's when I sort of backed slowly away and said, "Yeah, I can't help you. You're on your own, friend." If we're going to share code, it's got to be in a library. I've seen far too many instances where people assumed they were going to be installed alongside another application, and then I can just call it because I know it'll be there because your app has to be installed next to me. I remember at one point our sort of base image had so much extraneous stuff on it because this was the typical approach people were taking. I want to explicitly define dependencies. I can't just rely on something being there. If you need it, you have to declare it. We want our configuration separated out from the code. So basically anything that's going to vary from an environment to environment, we will want to have that separated out. In other words, can you open source that app right now if you wanted to? We're going to treat backing services as an attached resource, and that should be very easy for us to swap out a local database for a test database, which is really just loose coupling. I'm convinced that the zeroth law of software engineering is high cohesion, low coupling. That's such a core part of almost everything we're trying to do. If you look at the Gang of Four patterns, many of them are ultimately an implementation of high cohesion, low coupling. We want this build, release, run life cycle, and that's just another way of saying deployment pipelines. Shameless plug, but we actually have a piece on the developer portal on CI/CD to help people get up to speed on that. And it's one of those things that's important, and a lot of people are doing at least parts of it. But the goal here is you want a step that builds the executable, sort of merges in that configuration with that executable, and then goes ahead and puts it into the proper environment for you to then go ahead and run it. Now, we want things to be share nothing. I mean, obviously, state is a bit of a pain, and I alluded to this tweet earlier. My friend Stu sent this out last year. If you don't think managing state is tricky, then why is it 80% of problems in complex systems are fixed by rebooting? Somebody sent something out, describe software engineering in 3 words, and I think my response was, try rebooting it or something like that, or have you rebooted it? I mean, it's so silly how often that actually does solve problems. Now, that isn't to say you don't have any state at all. I mean, you have to have state. I think any of us that have a bank account or a 401k really wants to make sure that that state is managed somewhere. But what we're saying here is state has to be in some kind of durable backing service. It can't be in the file system. It can't be in memory because I can't rely on that particular chunk of memory or file system being there when I come back later. If I rely on the file system, if I rely on memory, it hurts my ability to recover and scale. I can't just add instances because the next request comes in, goes to a different instance than the one I was talking to before, and now some information I expect to be there's gone. I need to export services via port binding. So our apps are going to listen on a port, and that's where they're going to get their incoming requests from. So that'd be local host for development, a load balance for public facing side of the equation. Want to scale via process. In other words, we're going to scale horizontally instead of getting bigger and bigger hardware. For a shocking amount of my career, our performance problems were usually fixed by, don't worry, in a couple months we're getting a bigger server. And then eventually you sort of run into that world where, wow, clock speeds haven't really changed that much. Maybe I have more cores, but that speed of light turns out to be a real thing. And so now we typically just have lots and lots of little instances is usually an easier way to handle this. We want things to start up fast and shut down fast. These things are not pets. They're not going to be around forever. They have to be considered disposable. So if we need more capacity, we can quickly add it. If we want to, then that demand slacks off, we want to be able to easily shut that down. And these startups need to happen very quickly. We want ideally things to start up in a matter of seconds. If they wait too long, the health checks fail. So part of the way all these systems work, there's sort of a brain sitting in front of it that says, okay, you asked for me to have 5 instances. I see there's only 4. Let me spin up another instance. Okay, is that instance happy and healthy and ready to handle traffic? Oh, it's not. Okay, how about now? Oh, it's not. Oh, it must also be sick. I need to start up another one and another one and another one. And of course, our apps also need to handle the fact that you're going to be terminated too. That if we added extra capacity for a surge in demand, we can go ahead and ramp that down smoothly as well. Once you're finished with this particular process, we're going to go ahead and shut you off. And so our apps have to be designed for that as well. We want dev prod parity. Again, I've never once in my career said, boy, I really hope prod's different than all the other regions that I've tested in. And what we're trying to get to here ultimately is that path from customer asks us to make a change to that change is running in production is as quick as possible. And maybe that's hours, maybe that's days. Hopefully it's not weeks, and God forbid it's not months. Now that does, of course, imply that as developers, we're part of this whole prod ops cycle. This isn't just pitch it over the wall and let it be somebody else's problems. And of course, we want our environments to be identical, or at least as close as possible to identical, which means we do want our backing services to be the same between dev and prod. I have seen instances where people will use one dev in database, or one database in dev, a different one in prod, and shockingly, there are problems. No one could have predicted this. We do need to treat our logs as an event stream. This is a bit of a shift because many of us are used to just sort of going to a specific spot on a file system and then command Fing our way through a ginormous file and seeing the same thing repeated again and again and again, trying to thing that helps us understand what happened. So we can't do that anymore because I can't just come back to that file system later. So we have to stream that somewhere. So we just write our logs to standard. That's actually a very easy change to make from an application perspective. But then we go ahead and consume that in some other way. And frankly, this tends to be a huge win for us because now I can use a whole bunch of different tools to consume that. And they tend to be a lot more powerful than the typical text editor that most of us were stuck with for a lot of our development career. We do want our admin tasks to run as sort of a one-off process inside this same environment. So if we're doing a database migration, for instance, this is essentially a REPL inside that same environment as where the long-running processes live as well. Now, there's a pretty good chance that your legacy apps will violate some set of these factors. There's a chance, although it's not likely, that you violated all 12. Now, if you somehow managed to build an app 10 years ago that's fully 12-factor compliant, I very much want to have a conversation with you, but not about technology. I'm much more interested in your thoughts about, when the pandemic might end, what the stock market's going to look like in a year or two, maybe once sports comes back, where should I be placing some bets? There's a way to monetize that gift if you somehow managed to figure this out a decade and a half ago. Now, in general, the ones that we see a lot are explicitly defining your dependencies. This is one we've all failed at some point or another. You sit there as a busy developer and you're like, oh, do I really need this library? I don't know. It works. Don't touch it. Don't breathe on it. It's fine. And to take the time to pull it out and do the testing, a lot of us just sort of throw our hands in the air and say, forget it. We'll just let it be. Configuration separate out from the code. Okay, every one of us at some point has hard coded a credential or hard coded a database connection, and hopefully you caught it before it went to production. But that's always a lot of fun when you're like, hey, this looks like test data. Oh, because I'm pointing at the test database. Oops. Stateless, share nothing. This is another one I violated repeatedly. It's really easy to just stash something in session. It's really easy to build an app that's designed around a specific page flow that someone goes from page 2 to page 3 to page 4. For much of my early web development career, it's very common for us to say, oh, no, just put that in session. We don't want to waste time going back to the database. That's so long to go back to the database. So just store it in session. And then we discovered that once you load balance that, it hurts. And you're like, oh, okay, we made some mistakes. We were so young then. Startup fast, shut down graceful. This is another one of those things that I personally violated a lot. I've built a lot of apps that take far too long to start up. And of course, part of that's because what are we going to do on startup? We're going to go call the database 10,000 times, put a whole bunch of stuff in memory because, distributed caches weren't a thing yet, or they were slow and we didn't want to use them, or they were expensive and we didn't want to use them. So we'll just put this all in memory and that'll be fine. And of course, that doesn't really work because now it impacts our health checks and, bummer. Dev prod parity. All right. Well, we want consistency. Again, I've never wanted inconsistency here. I've never wanted to add variables to the process. What we do is hard enough. Thank you very much. But we're ultimately trying to shorten that code to prod cycle. This whole it worked in test, but not in this region just drove me mad in my development career. It's just no fun at all. Like a friend of mine actually had stickers made up at one point that said works on my box. And if you uttered that in a meeting, he'd slap that on your laptop and he did not mean it as a badge of honor. This was something that he meant to shame you into never saying that. Now, I've had this debate before. Does your application have to be fully 12-factor compliant to get any benefit out of the cloud? And I've had architects flat out saying, "Oh, if we're not fully 12-factor compliant, there's no point being on the cloud." Totally disagree with that. It's a great goal, to be clear. And if you have the time and the ability to get your application fully 12-factor compliant, awesome, knock yourself out. However, I am very much of the opinion that we need to be ruthlessly pragmatic, that certain things are more important than others for sure. And so we have to understand that certain attributes are going to prevent us from getting the full advantage out of the cloud. And so we need to look long and hard at that. For example, if I have very long startup time, well, that's going to make it hard for me to do elastic scaling and self healing. So I probably need to solve that one. Others I might be able to get away with. It just sort of depends on what matters, how much I want to invest in this application, what I'm trying to get out of it, how long is this application going to be around. It's ultimately a continuum. So if we think about this sort of like 12-factor compliance across the bottom, benefits kind of up and to the right, the further down that path I go, the more benefits I get. However, I do not have to go all the way down that path to still get benefit out of moving this app to the cloud. Now, you will hear people talk about 15 factors beyond the 12 factor. At the end of the day, however you define it, if we're trying to maximize what the cloud gives us, we need to make sure that our applications are designed to take advantage of what the cloud gives us. Imagine that. And so, yes, an application from 10 or 15 years ago is probably going to fall short a little bit. That's okay. It's on us to opportunistically refactor. And again, we need to be ruthlessly pragmatic about that. If we're building greenfield, well, outstanding. Go native from the beginning. There's no point in trying to build legacy right off the top. Now, I mentioned this before, but there's a fairly heavy bit of DevOps SRE that's a part of us being able to do this at scale successfully. A lot of us can probably argue that our DevOps is really the people who fill out the tickets so the developers don't have to. And I guess that's better than me having to fill out the ticket, but it's not necessarily that revolutionary change we were all hoping for. And I do think that's at least part of the reason why you see this sort of move towards site reliability engineering. I mean, that combined with the fact that, wow, these environments are very different than what we've had to use before. The moral of the story is this traditional sysadmin approach is not designed to give us reliable services because there's an inherent tension here. There's conflicting incentives. As a developer, I want to release early, release often, try new things, always be changing. But that runs right into conflict with our sysadmin prod ops people because they want stability. They're typically incented on that. They are rated on that. This is where raises and bonuses and promotions come from. And so it's in their best interest to push back and say, no, Nate, it works. Don't touch it. Don't breathe on it. Now, I didn't fully appreciate this until it's probably almost 10 years ago now. I was having this conversation with the woman that ran our DevOps function at my then employer. And she was telling me how much she hated Mondays, and not just because, oh, I got a case of the Mondays, because she knew that the CIO is probably going to drag her into his office and chew on her for an hour because big important system says they can't test because your regions aren't stable. And so she learned after repeatedly being chewed on that, okay, I'm just going to pour concrete all over the environments. Nothing will change ever. And then you can't blame me for your problems. Now the environments are quote unquote stable. So there you go. Now, of course, it wasn't her fault. She was a convenient scapegoat, but what ended up happening is everything was ossified because of the incentive that she was given. And so this is where you see a traditional trench warfare approach, this sort of fighting that we have. And it doesn't have to actually be that way. We can get along, but it does require us to take a different view on this. So SRE ultimately is just saying, hey, what happens if you ask software engineers to design operations? And I do think it's a little presumptuous that developers, our first reaction whenever someone says, how do we improve it, is to say, well, let's make it more like software engineering. We did this with testing. Now we're doing this with sort of operations as well. We even done it with our BAs. My wife's a BA. I'm sure she would agree with me at least somewhat on that. Ultimately, at the end of the day, this is software engineering applied to operations. Replace manual tasks with automation. Automation is your friend. There needs to be a strong focus on engineering. A lot of people that get into this space are, in fact, former software engineers that perhaps have an understanding of Unix or networking. At the end of the day, our operational approach must evolve in these environments. I spent almost my entire career dealing with some form of review board or another that would meet on a semi-regular cadence and then rubber stamp your application because of course they didn't know enough to be able to say whether what you're doing made sense or not. And that kind of worked, I guess, as long as you didn't want to release things quickly. The challenge for us today is we want to move fast, but we want to do so safely. There's that adage that says, "Oh, we move fast and break things." And of course, that's great if you can get away with it. But most of us have a mandate to move fast, but not break things. Move fast and fix things. And so, how do we have an operation that can support these dynamic environments? And that's really, I would argue, what we mean by site reliability engineering. That in order for us to have these stable, reliable services, we need a stable, reliable environment for that to happen. Now, sadly, none of this happens in spare cycles. Your SREs have to have time to do actual engineering work. If they spend all of their day on call, doing tickets, doing manual tasks, guess what? They're not going to get any of the engineering work done to make things better. And so, really, their focus needs to be on how do we automate away the toil, aka all the manual work that exists. And so, part of that is containing the technical sprawl. I mean, if you thought sort of suburban sprawl was bad, you should see what happens in a lot of development environments when we end up having every tool ever imagined under the sun. Because that's part of what we see with microservices. Everyone's very excited about the fact that it's awesome. I can use whatever I want. I have my favorite language, my favorite tools, and I get to use them all because microservices and developer autonomy. And so before long, you look around and go, wow, each team seems to have its own pipeline and its own preferences and its own metrics. And now we don't have a couple of ways of doing it. We have 100 or as many apps as we have is how we do things around here. It's pretty hard to staff up in that environment. I mean, there isn't a developer around that knows every language you have and all of the ancillary stuff that goes along with it, plus the cloud environments, plus your automation, plus this, plus that. How do you support all that? How do you stay current on all that? I think we're all well aware of the fact that these hacks that are happening today are frontline news and people are losing their jobs over it. And unfortunately, these flawed pieces of software still exist in the environment. And every time I turn around, there's a new largest hack ever. Equifax and was pushed aside by Exactas, which was pushed aside by the Starwood chain, now part of Marriott. And so we have to be very cautious here. It can't just be a free for all, do whatever you want, live your best life. There's got to be some guardrails in place. And some companies have a pretty wide latitude. They say, use whatever you want as long as it lands on the JVM. We're cool. Previous organization I worked at said, you know what? There's 3 flavors. You can use Java, JavaScript, or C#. If one of those isn't going to work for you, come talk to me, and my job will be to say you're wrong. Now, obviously, if you have a good reason, we'll work with you on that. But generally, our job was try to make sure that we went into what we think about as paved roads. That's ultimately what even the most ingrained developer autonomy organizations like a Netflix, that's what they're doing. It isn't a true free for all. There are guardrails in place. Here are the things that we use. These are the things that we understand. This is a well-worn path. We know how to support it. We have examples of hundreds, if not thousands, of applications going through this successfully. If you want to go down that minimum maintenance road, knock yourself out, but you do so at your own risk. You build it, you own it. Now, of course, sprawl tends to exacerbate our accumulation of technical debt, which should make you think about our good friend Uncle Ben. With great power comes great responsibility. We have to be prepared to, all right, if I'm going to go down this path, I own it. I built it. I have to run it. Now, some people would argue with me, Nate, this sounds like DevOps. I think it is. It's sort of an extension of that, maybe a specific implementation detail of that, if you will, but it's getting us to a similar place. So let's talk a little bit here about culture. Now, I know that seems a little weird for a technical thing, but one of the things that I've realized trying to bring cloud into organizations is it can be a bit overwhelming for a lot of us. And, you know, for many of us, when there's a lot of change, what ends up happening is our lizard brain activates and we instantly go, whoa, change bad, stop change. And the thing that I've noticed trying to bring these kinds of things into orgs is we have to have a pretty heavy dose of empathy and compassion. And we have to ask ourselves, how do I approach someone with these new ideas for someone who hasn't seen this before, maybe doesn't have my level of enthusiasm? And, you know, I think we all sort of have this idea that if I'm excited about it, everybody is, and it's a great idea. So why wouldn't you support this? And that's not always the case. I remember many, many years ago, I was at the corporate picnic and I ran into a friend of mine I hadn't seen in a couple of years. And I said, "Hey, Al, how you doing? You know, how's everything going?" And she said, "Oh, I don't know, Nate. I'm on one of these agile projects." And I will admit that my first reaction was to kind of, roll my eyes and be like, okay, waterfaller, I see where you're coming from. But then I thought about it a little more. I thought, here's the thing. Althea's been delivering code to production for years. She's written thousands and thousands and thousands of lines of successful software. Billions of dollars have gone through systems that she's worked on. And someone like me comes along and says, the way you've been doing it your entire career is wrong. I'm here to show you the right way to do it. That's just not a good way of getting someone invested. And it's on us to help them understand why this is in their best interest, to understand the journey that we're all going through as we adopt a new technology. You have to remember that these when we're talking to someone who's new to this, they're where you used to be. And the challenge for us is, all right, I know how to get you to where I am. I might be able to get you there a little faster because I know where the potholes are, but you have to walk the path. I remember my transition to Git. I used to be a very happy Subversion user, and a friend of mine's like, "Oh, Nate, you need to watch this tech talk," and I did, and frankly, I was kind of insulted because for about an hour, he just sort of insulted anybody who had used anything other than his shell scripts, and I thought, well, that sucks. I don't want to do that, and but I gradually got reintroduced to it. One of my friends gave a great presentation on it. I started playing with it, and I recognized the power here, and before too long, I'm like, "You'll take Git from my cold dead hands." But it took me time. That wasn't an overnight thing. And so when you're introducing these ideas to companies, it can be very helpful to do a day in the life, to walk someone through, this is what will change for you. Yes, the tools will change, but that thing you hate to do, it's going to go away. And so we need to understand that the culture will change. It just takes time. I wish it was an overnight thing. I wish there was a magic wand I could wave, but there's not. And so we just have to remember, as my friend Alan says, it's a process, not a destination. This again is not the kind of thing that happens in spare cycles. You need to use positive reinforcement. You need to use the guardrails, the paved roads. Again, here's a well-worn path. We know how to support it. We know it works. If you venture down that minimum maintenance road, you're on your own. You have to embrace that idea that you build it, you run it. You need to be prepared for the fact that, guess what? Your systems are going to fail. That's okay. You can't prevent everything bad from happening, but you can be prepared for it. You have to be ready for the fact that your resources do not, in fact, scale to infinity. There will be competition between teams for hardware, staff, priorities. There's always a battle for headcount. I've never seen some manager say, "I'm good. I don't need anybody else." I've never seen a VP say, "My portfolio is just not that important." Who could have possibly predicted this? I really want to emphasize the cultural shift part of this. Again, I know we tend to get very focused on the technology. I get it. That's what we love to do. It's what we're good at. The culture parts are hard, but it's vital to our success. So I'm going to go ahead and pause here, turn it back over to Mr. Brindley.
Hey, that's me.
Yes.
And I'm here.
Yes, you are.
We're all here. Well, thank you very much, Mr. Schutta. That was wonderful. And yes, I think really with any business, the cultural part is the hardest part. And obviously software, we try so hard to make software easier, but it's that cultural part that really snags people up sometimes, companies, corporations. So the rise and fall of a corporation can be from the cultural, not from sticking up with, keeping up with the technology in the recent times. So anyway, cool. Well, thank you. And thank you all for listening. We really appreciate you sticking around. A quick note also, we are going to put this on our YouTube channel. So we have a Tanzu. Oh, one of my coworkers joined me up on my lap. I have three furry coworkers, but anyway, we have a YouTube channel that is Tanzu. That's because of the Tanzu channel, in fact, TANZU on YouTube. And so this and tomorrow's will be posted on that as well. So all of that content can be seen. Clearly, give us a few days to post it, but it'll be up there shortly. Anyway, and with that, let's all take a bio break, everybody. We'll see you back here in a few. And Nate and Jakub are going to walk you through some fun fake problems, but they might hit a little close to home. They might actually feel like a real problem. So anyway, we'll see you back here in a few minutes.
Hey, Daddy, what are you doing?
I'm telling people about a way to be more productive in the enterprise.
Ooh.
As you can tell, I haven't really had the chance to regularly take a shower or get to my barber. There's one little anecdote I was going to go over as a way to, I'll be frank with you, hustle you downloading my book. Over at Allstate, this is some years ago, I heard that they wanted their developers to be more productive. So they were basically like, you know what you should do, they being the managers, is go to less meetings. But what they found is people actually hadn't kind of taken that seriously. I mean, often when managers say stuff, you never really know if it's true. So what they did instead, because people were still in meetings, is their managers would send out meeting requests that were, 4 or 5 hours a day that just basically said, don't go to meetings. We're serious about that. They blocked off their calendar to really show their seriousness.
Hey,
But if you go to cote.pizza, you can get a link to the book, the O'Reilly book, where I go over that, and another book that I wrote more recently, and kind of go through actual tactics that people use. It's not your usual sort of column or content that's just like, digital transformation is important.
A lot of people tell me that they have problems with compliance. When you've got like a centralized automated platform in place, something like a Tanzu application server, you're automating a tremendous amount of what goes on the infrastructure layer. And it also turns out you're not really changing that much release to release. Now, someone like the US Air Force, they put this in place. So what that allowed them to do once they built the trust with the auditors was they went all the way from 18 months, which is a very long time, but important if you care about controls, down to about 10 days or so, because all the auditors had to look at was that little part of code that was changing on their small iterations. A lot smaller window, a lot easier to do. So if you want to see more about that, what you can do is go to cote.pizza, and you can get this book that I told this anecdote from for free, and a whole lot of other stuff. And you can dig into the details. Even people with the largest portfolio of applications can't do everything at once. And so I see this a lot in people I talk with. They start with a small handful of applications at first. They start with maybe 1 to 5, whatever. And then as they learn how to do new things, they ramp up to more and more applications. In fact, you kind of see a flat sort of curve and then a hockey stick. And the reason that you're doing this, the reason you're starting small and going big, is you're learning how to use a new set of tools, and you're kind of going to not always be successful at it. Most of the time what they do is they pick applications that are real, that are business facing. This might be like a store finder application, or even sort of like where you rent paint from a paint desk. And then what they do with these applications is, as they're successful with them, they use them for internal marketing, and they've proven out how this methodology works. And they're given permission to do more and more of these types of applications. So if you want to see more about that, just go to cote.pizza, and you can look at a couple of the books that I have there that kind of lay out doing this tactic.
All right. Thank you so much. Hope everyone was able to stretch their legs, get a quick beverage, bio break, what have you, because we got some great content coming up for you. Yes, Jakub's ready. Got to keep them vocal cords all lubricated. All right, Nate, how are you? Thumbs up. Good to go?
Fantastic.
All right, wonderful. Well, everybody, this is Nate and Jakub going to walk you through a problem and how they would help solve it. And again, this is a fictional problem, right? This is not a real case.
Nope. No real projects were harmed in the making of this.
Correct.
This section.
All right, well, wonderful. Take it away. Go ahead.
Just before we start, I want to clear one thing. I have had my hair done, but now in Poland, it's totally legal since 2 days, okay? So I just want to make it clear. Yes. I didn't break any rule, any law. It's legal since 2 days in Poland, so Jakub, I have it done.
Never break the rules.
No, you are quite the
I'm ready to sport a new haircut, because this is as long as my hair's been in probably 10 years, so I should really do something different with my hair. I'm taking suggestions, so.
Well, this is the shortest my hair has been in 35 plus years. Probably.
You wear it well. You wear it well.
Yes, we got the quarantine cut going on over here. All right, gentlemen, off and running.
All right. I hope you see my screen.
Looks good.
So I want to start with a controversial statement. In my humble opinion, there is no such a thing as good architecture. There is not such a thing as good enough architecture either. No such a thing as generic good architecture. Why? Because architecture, it should be aligned with business needs, right? So to assess architecture and the design, we need to understand the problem it is trying to solve. Let's take an example. When you want to buy a car, there are different choices and different decisions depending on what you want the car for. Like, for instance, when you want to drive fast, you pick a sport car. When you want to drive safe, you probably pick a family car. And when you want to pack your golf gear, you need a roomy car, probably, right? I have no idea about golf, by the way. I just imagine you need space for that. My buddy, Nate, he plays golf, so probably he knows more about that. He knows a thing or two. So a car is a good or bad choice only in relation to its purpose. Same applies to architecture. By the way, except for one car, this car. Do you know that? Is that a thing in US? We have a good laugh about this in Europe. It's called fiat multipla. Is that a thing in US too, Nate?
I don't think so. I've not seen that, to be honest with you, but it looks like an abomination.
This car is always a bad choice. Like, just look at it. Just take a look. I can't imagine this thing being a good choice regardless of the circumstances. So except for fiat multipla architectures like car, okay?
That's a lot of
it's
headlights.
good or bad. Yeah, it's pretty awesome, isn't it? Anyways, to choose a correct architecture, we need to understand the problem. As Eric Evans wrote in his famous Blue Book, the biggest problem in software development is understanding the problem itself, understanding the domain itself. Most of the problems, they will be hard to grasp at once. This is why we need to apply the divide and conquer technique, right? We need to decompose the domain into smaller sub-problems, aka subdomains. If you think about it, it is the good old-fashioned principle of high cohesion and low coupling. This is what Nate was talking about like 1 hour ago. I want the things that change together to be composed together. And I want the things that change because of different reasons to be separated, right? But how to do that? Well, that's the crunchy stuff. That is the hard stuff. And we are going to talk about this more later on. Just one thing, one clarification. When we talk about decomposition, I'm not talking about deployment. So I can have a nicely decomposed software and still deploy it as one deployment unit, as a monolith instead of set of microservices, right? And then at the end of the day, some of the chunks, they need to talk with each other. We need some sort of integration, right? And by the way, I have made all of the drawings myself. Sorry for that. I needed to justify, just in front of myself, the purchase of iPad and new pencil. So I just needed to use it somewhere. So I just made some drawings. All right, but how to understand the business problem, how to understand the domain. I would like to introduce the technique which is called event storming. What is event storming? It's a collaborative technique designed to improve the communication between IT and business people. One of the outcomes is that it facilitates the composition of the problem, giving you an opportunity to model subdomains, to model new flows, new business flows, processes, etc., etc. So it's a group activity that requires some sticky notes, Sharpies, tape, modeling space, like a large wall, for instance. And this is a time lapse of an event storming session I have had with one of my clients before joining VMware, before joining Pivotal. So it took us more or less 6 or 7 hours, I don't remember correctly, to understand the problem. So how does it work? As a group, we together, participants together, storm the business processes, writing down domain events on sticky notes, right? We focus on the happy path for starters. So we focus on the happy path to begin with, and then use past tense for events. You might want to introduce other colors like purple for policies or red for hotspots, things like that. Because, you know, as your team works through the business domain, you will find trouble spots. You will find some external systems that you want to be represented on the wall somehow. And once you've brainstormed the events, you will have to work with domain experts, with all of the people who are there. So IT people, business people, you work with them to enforce a timeline, which will often, very often, uncover some missing events, missing elements in your on your modeling space. So once you have the timeline, look for potential subsystems, so sub-problems, so the composition that we've talked about 10 minutes ago. How to identify the subdomains? So we can look for events that transition across subdomains. Those will be often like candidates for boundaries of two different services. We're going to talk about this later on. By the way, the inventor of event storming technique, Alberto Brondolini, he calls such events pivotal events because they change the rule of the game. So normally you do the event storming session on site, of course, but taking into account the current circumstances, me and Nate, we have created an online board beforehand just to play around with. Okay. Now I'm going to share the board and introduce our fictional business problem. All right, so let's take a look. Cool. So this is the legend. Our system that we are trying to build, it's called Docflow. Docflow serves as documents circulation system. And document, by nature, of course, is the main artifact of that system. The main flow of the system, the main flow of the document looks as follows. Let's take a look. We have an internal author, and the document is created by the internal author. So we have an actor, that's this sticky note. We have some events, orange sticky notes, like this. At this point, the document is just a draft. Okay, so there is no need to specify neither the content nor the title, although the author, he or she might want to do so. All right. Of course, author, he or she, they need to specify which departments in the organizations have to get familiar with the document in here. And all of the changes that the author does, they need to be audited. That's why we have this audit policy. So there are different ways in our system of doing audits. Sometimes we just store snapshots of the documents, of some parts of documents, which is not really a pure audit, just a history or history of parts of our documents, right? Sometimes it's just a diff log, which might lead to techniques like event sourcing, etc., etc. So we have different ways of doing the audit. And at this point, during event storming session, we don't want to go down here right now to identify all of the things that are related to audit, because we might end up with so-called analysis paralysis. We want to focus on the happy path, right? We just note that the system needs to be elastic in here, and the requirements might change even in the runtime. We note it with a policy. That's why we use policies. Purple notes. I hope that's purple. I'm a little bit colorblind. I think it's purple.
It looks like purple to me. I think it's good.
Yeah. Thanks, Nate.
That's a great point on the analysis paralysis, by the way. It's so easy when you're doing these kinds of things to sort of spin down, get really caught in the weeds, and that's where it's valuable to be able to kind of take a step back and say, well, let's just throw it up as a note, and we'll circle back to it.
Correct. And it will definitely change. So you want the system to be elastic in this place, because you know what? If we don't know right now, probably we'll change our mind tomorrow or the day after tomorrow. So make it elastic. That's why we need policy. And then we have an additional process. So we mark the processes with those yellow labels. We have attachments that can be added or removed from the document. Like an attachment might be a different document. It might be an MP3 file. It might be a large MP4 file. And every attachment, of course, needs to be scanned with an antivirus tool before it can be added to the system. The company already pays for the antivirus software subscription. And they can be very large files, which requires huge processing power. So probably we need to scale in here. We need scalability in here. And we might want to mark it as a hotspot, like this. We need to scale. And we have it done. We have the note about this, and let's move on. All right? At some point, a version of a document is created, ready to be verified. In here, the document version was sent for approval. Of course, you can revert, and at some point, you create a version which is ready for approval. And then what? And this is the event that we have talked about. Like, if you see during event storming session that there is one event which is a point of interest for many people from different departments, this might be a good candidate for the boundary of two services, right? Because there will be people interested from this department, people interested from this department, and so on and so forth. It's a good candidate to be the pivotal event, the one that breaks our system into two different services. Okay, let's go further. Then we have verification process. So the notification has to be sent. Again, we have different ways of notifying people. Some of them use emails, some of them use push notification, etc., etc. At some point, the document needs to be accepted by the quality manager, right? And the important stuff is, after the verification has started, the document cannot be modified. Of course, you can create a new version, but this version cannot be modified, all right? And then, if the document is accepted, of course, we pass it to top management, and top management needs to approve that. So it's like a two-step approval / verification process. Of course, the quality manager or the top management, they can reject the document and it goes back and nothing happens. At some point, if document was verified and approved by quality manager and then top management, the document is published. Right? The publication was requested. We have, again, publication policy. We have different ways of publishing documents, sending emails, putting some stuff into Jira, maybe notifying our HR system. Again, the system needs to be elastic in here. Previous version was archived. Acknowledgements were created because every person who needs to see that needs to also acknowledge the fact that he or she has seen the document. All right. And you know what? All of the employees rated from related departments, they need to be notified about new document, right? And some of the documents will be printed out and handed to people who don't use computers, because there are some people in the company and then they don't use computers. So those people will have someone like department manager to approve the documents on their behalf. All right, super simple. We have some delay policy, of course, how many days you have for approval, for acknowledgement, and so on and so forth. And then at some point, we have the archivization process. We have some expiration policy. The expiration date was set at the time of creation of the document, and then the version is archived. That's it. That's pretty much it. So, of course, it takes more than 5 minutes. It takes like up to 3 days, maybe 4 days, depending on the complexity of the problem you have and the number of people you have during the event storming session, discussions you might have. But at some point, you might want to see where are the possible boundaries for the composition. All right. So here are the proposed boundaries that we found with Nate, like preparation. So all of the services, independent services, are marked with this green label. Preparation, approval, publication, acknowledgement, document archivization. All right. Again, these are proposed boundaries, independent business-facing pieces of the entire system, of the entire problem. Please bear in mind that we are not talking about microservices, just independent chunks of our huge business problems that can be, again, deployed as a set of microservices or maybe as a modular monolith. We don't know that right now. So the bad news is that there is no algorithm for decomposition, no step-by-step method that you can apply to get the perfect architecture. Bad news, right? If there was such a thing, we wouldn't need architects, right? Computers would do that. It takes intuition, experience from seeing many different problems, many different domains, many different projects, and it takes some knowledge, of course. You want to have autonomy in each of the green parts. So you strive for the boundaries which give you the highest possible autonomy in each of the chunks. Any questions so far, Nate? Is it clear?
So I think one of the things that's always important to highlight when we talk about these divisions is often one of the things that gives us a clue there's a boundary here, whether you want to call it a submodule, a bounded context, a subdomain, is that the same term has different meanings from this chunk to that chunk. So I spent a lot of my career in insurance, and while you might think conceptually that a policy is a policy is a policy, well, there's a big difference between a business policy and a personal lines policy. But then even within that, the way the billing part of the company looks at policy versus the underwriters versus the claims group, policy is not really the same, even though it's the same term and has a lot of the same attributes hanging off it. So with that in mind, Jakub, do you want to touch a little bit upon kind of how we sort of got these particular breaks and sort of why there's a preparation and approval and how we sort of arrived at this, kind of how did we bake the cake, so to speak?
Sure. So I have a bunch of heuristics to use when I want to decompose software. Of course, it's these are heuristics, so it's not an algorithm, but one of the heuristics is the one you mentioned. So different language or the same language, but with a different meaning depending on the people who talk about it. So let's talk about preparation and approval. Why our proposal is to split those two things into two separate services. So look, do we need content when we prepare the document? No. Is there any validation in here yet? No. It's just an audit of changes and some versioning, right? In approval, on the other hand, we need a snapshot of a version. We need the snapshot of a version at some point of time, right? And we cannot change it later on. But we can still have different versions, and then the snapshot cannot be changed. So the heuristics I have used in here to divide those two is that those two, they have different reasons to change, right? I can change the document that is being prepared, but I cannot change the version that was sent to approval. Plus, there are different actors, like there's top management, there's quality manager in here. And here on the left side, we have the author only. So there is only author, which means there was some kind of a handoff between the left side and the right side. It's a good heuristic to use to decompose the software. It goes down to this pivotal event. Document version was sent for approval. The only connection is that pivotal event, by the way. We have talked about, right? We have talked about it. It's the point of interest for different departments. You might want to call this thing on the left side a draft model. And on the right side, on the other hand, it would be something like, I don't know, operational model. But it's a different model. We have validation in here. We have different rules in here, different reasons to change, etc., etc. And by the way, the same idea we applied to create publication and approval as separate subdomains or modules or whatever we call them. That's the same idea, right? We have different language in here. We have different actors. We have different reasons to change. So that's these are the first 2 or 3 heuristics I use. Again, why? For instance, publication was separated from acknowledgement. That's a little bit tricky, but I would use the same heuristic that Nate mentioned. So think about an area of consistent language. Let's take a word document into account. Does it mean the same thing in publication? And does it mean the same thing in acknowledgements? Does it come with the same verb associated to that noun? I don't think so, right? In publication, we have publish, probably unpublish, whereas at the acknowledgement side, we have ACK, we have probably negative acknowledgements, expirations, and so on and so forth. So there is a different language associated to the same name, which is document. So it might want to lead you to the conclusion that this is a separate bounded context. Bounded context is the area of consistent language. In this specific context, a specific word means exactly one thing, like document. Same with acknowledgements. In here, document means something concrete, but it's something different than in publication. So that's another subsequent heuristic, the area of consistent knowledge. And think about it. Acknowledgement is just a collection of ACKs, right? Nothing more than that. Today, we acknowledge having read the document, most possibly tomorrow you acknowledge having done a task or something different. So it seems like a generic problem, not only related to documents that I have to acknowledge something. It's not possibly only related to documents. If you see this generic problem in your domain, most possibly it can be done as a separate service. Probably there's already software which deals with that kind of problems, right? And then we have archivization in here. Why is that yet again a separate subsystem? So in this case, let's imagine we have domain experts just solely responsible for doing this process of archivization, because they know the law, they know the rules, they know all the crunchy stuff that needs to be done when you want to archive the document and meet all of the requirements depending on the country you are in, depending on the law you face, etc., etc. So if you have a domain expert that is their only job is to do something, probably that can be a separate subsystem too. That's of course a heuristic again. So we have used like 3, 4, or 5 of those, and this is a good start to validate if that makes sense. So how can you validate that? For instance, you take an example, you walk through your system and see how many communications between modules you have. If you have all the time going from module A, B, B to A to B, B to C, C to B, B to A, etc., etc., probably that's not a good design. A good design is such a design in which you have a limited number of integrations, and all of the modules, they are as much autonomous as it can get. Does it make sense, Nate, to you?
Yeah, and I just want to emphasize the point here that these are heuristics, that a lot of what Jakub is talking about and what we arrived at here, it's more art than science. And some of it is just, this feels right, putting it here, and this isn't quite right, let's try this, and then realizing, well, these two things actually we can combine, or you know what, there's too much going on here, let's break it apart. You're not going to arrive at this in an hour. I mean, I know, Jakub, you've done a lot of event storming sessions. These things can take days, to really get to it.
Cool.
And I think there's actually a lot of value in, all right, we're going to work on it for a couple hours, and we're going to set it aside for a day or two, let it ruminate, and then we're going to come back and spend another couple hours on it. So that the goal here is just to kind of work through it. It's a heck of a lot easier to do that, by the way, by moving some sticky notes than trying to shove code into production and go, oops, that's not a clean break. So don't be afraid when you're doing these kind of techniques to move stuff around. You don't let sort of perfect be the enemy of good enough, and just kind of let yourself walk through it. And it's really a fascinating way, I think, of finding these bounded contexts, finding these lines in the sand. And to be clear, some of these divisions are kind of arbitrary. It sort of seems like, well, this feels about right, we're going to draw a circle here. Your domains, you've got the right people in the room, so don't be afraid to let that expertise out.
Sure. One thing that needs to be emphasized too is that probably it will change during the life cycle of the project, right? Of the product. So be prepared. It's an initial idea. It might change next week. It might change next month when we do something different at our organization. So be prepared. Be prepared to change the boundaries, to move them around, to play around, right? How to do that? So again, the basic principle of encapsulation, high cohesion. Like, I don't want my internal stuff to be exposed to my clients. Why? Because then if I want to change the boundary, it's going to be hard. It's going to affect all of the clients that have used my internal things. So don't do that. Be prepared that the boundaries are blurry. They will change for sure at some point. It's not big design upfront. It is just enough design upfront to start with. All right? And how does it relate to microservices, by the way? What do you think, Nate?
Yeah, that was going to be my next question. Actually, two related questions. So we know things are going to transition sort of between these bounded context subdomains, whatever you want to call it. Do you have any thoughts on how to handle that translation? I've been at companies where they'll have the giant object model, and this is the truth about some domain. And of course, what you end up discovering in practice is there's not just one version of that. There's dozens, hundreds of them, because people will take a
Correct.
snapshot and modify it, because it's pretty much impossible to boil down these concepts to a one size fits all. I always like to joke that if you've ever seen a t-shirt that says one size fits all, you may have asked yourself, like, who are these all people? Because it looks terrible on everybody. And so you have to be real cautious about trying to boil the ocean there to say, here's the one unifying concept, that'll get everything to work. It's okay to make these translations that to you policy means this, but to my domain policy means that. Do you have any thoughts on kind of, as we cross those boundaries, what that looks like?
Yeah, correct. So microservices, I would state that they are not the ultimate goal, right? They are just the mean to some goal, like having an autonomous system. They are not the target itself, the goal itself. They are just a tool, and the tool, it has to be used wisely. They come with a huge number of benefits, right? But also they come with huge operational complexity that we have to deal with later on, and that complexity needs to be justified. So there is a need to calculate the return of investment of having this kind of an architecture in production. That's probably the most difficult architecture I have ever worked with, by the way. So how to identify the places where we should have maybe an independent service, let's call it a microservice or whatever. So one of the architectural drivers to look for is independent deployment calendars. So if your accountant, he or she wants to deploy every 6 months, and the marketing department, they want to deploy every 2 days, probably you need to separate, for instance, the marketing software into a separate microservice, right? Other architectural driver would be independent scalability. Like here, for instance, we had our attachments. They need to scale. They probably need to scale independently. Probably that's a good heuristic to put it aside and have a separate microservice that deals with attachments, large files, and so on and so forth. We're going to have more instances as the computing power, need for the computing power grows, right? Other architectural driver would be, I want to have failure isolation. So if the attachment service fails, I don't want the process of approval, acknowledgement, publication, and so on and so forth to fail too. I want to have isolation of the failures, right? Another architectural driver. I want to have a different technology stack because there is a need to have it in here. Again, it might be a good architectural driver to have a separate service. One last thing that comes to my mind is if I want to adjust to some legal compliance. Let's say I deal with sensitive data, like credit card numbers, and I want to be PCI compliant or something like that. It's so much easier to have it done in one small place, like a small microservice, than in whole monolithic application. But again, these are architectural drivers that can that can lead you into conclusions that, hey, here we need to have a separate microservice, but then the rest of the system, like preparation, approval, publication, and so on and so forth, everything except for attachments, it might be a modular monolith. So we have a modular monolith, let's call it a microservice, and then we have attachment service next to it. Does it make sense?
Yeah, those are some great principles. Someone should write those down and put that out, like on our blog, maybe, or maybe as a report that might be coming out later this summer. But I'm just speculating that perhaps there'll be a succinct report version of that within the next few months. Yeah, I think
you should do it.
I probably will. I'll work on that. Actually, I'm in the middle of doing that in case that wasn't just plainly obvious. Again, it's a good point that these are heuristics that we apply. They're rules of thumb. There is no magic recipe. If there was, you just throw this through some software, and out the other end would come this magical piece. And I think it's important to understand that you have to be ruthlessly pragmatic about all these things, even when it comes to, should this be a microservice, should this be a modular monolith. I think there's actually something that Spencer Gibb and I were talking about that. I think I want to share this real quick here, Jakub. I think I'm going to steal the share from you for just a minute.
Of course, no worries, buddy.
Yeah. So this came from a conversation that Spencer and I had a couple weeks ago, and it's based for sure on some of what Simon Brown has talked about around this. If you can't build a monolith, what makes you think microservices are the answer? And what we have to remember is, modularity is one thing that we care about, and then there's also this sort of distributability, deployability, whatever you want to call it. And so many of us are kind of living in this quadrant where we have a big ball of mud, which is shockingly like the most common sort of architecture for us to employ. And a lot of us are sitting there going, boy, I really want to get to microservices because that's the new hotness. And so we try to go, all right, let's go straight from big ball of mud to microservices. That sounds like the way to do it. But unfortunately, that's not really what happens. What happens for most of us is we create a distributed big ball of mud, which turns out to be the worst of all possible architectures. This way lies madness. And so what people do, I think, quite frankly, more logically, is say, all right, you know what, let's do a modular monolith. So we'll go there first. And then from the modular monolith, we might break out some microservices if that's what makes sense. Now, you're starting to hear a bit of chatter now about macro services. I think the right way to phrase it is it's right-sized services, which, we could have a debate from now until the proverbial cows come home about what is a microservice and how big should a microservice be and things like that. But, let's just be honest. We're just trying to find the right size for you. It should be as small as possible and no smaller, if you want to think of it that way. And so maybe now we go from the big ball of mud to the modular monolith to right size services, or we go from the modular monolith to microservices to, the right size services. It's really kind of up to you. And it's okay to sort of stop at the modular monolith level if that's the most logical thing for your application, if that's the easiest thing for you to support. So I just think it's important to understand that too many people go from big ball of mud to distributed big ball of mud in their effort to get to microservices without, of course, stopping to ask, should that even be a microservice in the first place? I'll hand it back to you, my friend. Now, just because we have that bounded context does not imply that there has to be sort of like a 1-to-1 ratio there, right? And so I think maybe that's something you might want to sort of chat a bit about here is within these bounded contexts, how do you break that down and into a microservice if that's what the right answer is for this particular problem?
Correct. So the idea is to find the architectural drivers, and then if you really need to do so, you apply microservice architecture. Otherwise, you pick an easier tool, right? Like you mentioned, maybe it's a modular monolith. Sometimes, in fairness, and I want to say it out loud, big ball of mud is a fair choice. Let's imagine that you are going to build something that is going to last in production for 2 weeks, and then it's going to be trashed because you are going to handle some discounts for Black Friday or whatsoever. Hey, what's the quickest way to build such a thing? I'm going to build big ball of mud, right? And then I'm going to trash it. So we have to pick the right tool for the problem we face. But okay, let's imagine we understood that the attachment needs to be a separate service, and everything else is just a pure monolith. Let's say that from preparation module, we have to talk with the attachment service, and in order for us to ask, hey, what's the status of this attachment? Is it added? Is it removed? Blah blah blah. So we just do HTTP GET every now and then. All right. But let's imagine that attachment service it's down-performing for any reason. And it means you have to wait a long time to get a response. And by the way, not only you have to wait a long time to get a response, but on top of that, most of the responses, there will be failures, timeouts, or possibly errors whatsoever. If you don't apply some smart solution here, quickly, your callers will be down-performing too, because you are down-performing because of the cascading failure of attachment service, right? So there is a research done by Google, Yahoo, Amazon, and they all say that it is better for the clients and for our user experience to inform our client, our visitor, that I'm sorry it doesn't work, but do it quickly and try again later on, than to make them wait for seconds just to see 3 failures out of 4 calls. It's just better for the clients, for user experience. So if you don't want to have it, you have to apply circuit breaking pattern. How does it work? Circuit breaker pattern detects failures at the attachment service or any external service you want to call. Any code that is not reliable, by the way, doesn't have to be an external application. So it detects failures and prevents the application from trying to perform the action that it's anyways doomed to fail. Until, of course, it's safe to retry. So let's do a quick demo. Let's jump to code and see how it would work. So we have a preparation service. It's a simple Spring Boot-based application, right? So we have here a REST controller. It's going to handle requests related to preparation. Why not? Preparation service controller. And then we have one endpoint, which is get. It's going to be /test. Why not? We are going to return string attachment status. Let's return OK for a while. And then let's simulate that we have an external service. It's called external failing attachment service, like this. And then here, we are going to simulate that our external failing attachment service is going to wait a little bit and then return almost all of the time some errors, like this. String attachment status. And let's do like this. Let's wait for a while, for starters, like 200 milliseconds. Why not? I need to try and catch, I guess. Yes, don't do it in production. It's just a demo. It's not here. It's not visible, OK? This line of code. It doesn't exist. Just ignore it. What else? And then, you know what? Not only we have waited like 200 milliseconds, which is not that quick, by the way, but also every second request will be a failure. You know what? Every 3 out of 4 requests will be a failure. And then at some point, you will get OK. So we are simulating a system, a subsystem, or maybe an external service, which is downperforming, it's lagging, and then every now and then, it also returns an error. All right. So here we are going to inject our external failing attachment service, like this. Final. Good. And then here we are going to delegate to our external system, like this. Cool. And now I'm going to run it. And let's do a simple test. It should be up in a few seconds, hopefully. Good. It's up. Now if I do curl localhost 8080 test, of course I got an error. No message available, blah, 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 internal service error, 500. So let's do 100 sequential calls from my machine to the service, like this, with AB tool. I'm going to do 100 calls, and each of the calls lasts at least 200 milliseconds, which means the whole benchmark is going to take more or less 20 seconds plus something, right? Because we have 100 calls, all of them are sequential. Each of the calls takes 200 milliseconds. So be patient, as the tool says, and we are benchmarking. And we are going to see that, yeah, the whole test took 20 seconds, 20 and a half. And we have 73 non-200 responses, which is more or less 75%, which is what we expected. The math works, right? So as you can see, all of the requests were longer than 200 milliseconds, which makes sense because we slept for 200 milliseconds. All right? So imagine you have more of them, more of them, more of them. You just wait. You block your application, and your clients are just mad. What you can do about it? Anyways, if the service is down, if the attachment service is down, what's the point of calling that anyways and waiting 200 milliseconds? It might be 2 seconds, might be 20 seconds. I just put 200 milliseconds because I want the presentation to be quick. So what you can do, you can apply the circuit breaker. How does it work with Spring? Spring Cloud Circuit Breaker provides an abstraction across different circuit breaker implementations. It provides a consistent API on top, for instance, of Resilience for J, Spring Retry, or in the old days it was Hystrix. Anyways, I'm using Resilience for J in my POM XML, depending on what you chose. It doesn't really matter. We have an abstraction. So I'm injecting Circuit Breaker Factory like this. Cool. And I want to create a circuit breaker like this. Let's call it CB. It should be Circuit Breaker Factory create, let's call it CB2. Cool. So let's create this. All right. Makes sense so far, I guess so. And now we can just decorate this call into a circuit breaker like this. And now this call will be actually calculated how many times it has failed. We have to configure how many requests are taken into account, and then if the threshold is over, the system will open the circuit and will just return quickly the error, and the client doesn't have to wait. Let's see if that works. Hopefully it works. So if I run the first test, it should just warm up the circuit breaker, so it should take more or less 20 seconds again. Hopefully the second test will be quicker. Let's see if that works. Because it has to calculate, there's a sliding window, like 10 requests, and like 60% of them have to fail in order for the circuit breaker to be open. All right, let's try one more time. As you can see, the second test is very quick, but we have 100% of failures. Why? Because we don't call the service. We just quickly return an error, but in this case, it's quick. But what if you want something different? Like, I don't want those errors to be propagated to the client. Maybe I want some sort of fallback. For instance, if I don't know the current status of the attachment, I don't want the error to be propagated. Maybe I'm going to call a different service. Maybe I'm going to provide a default value. So I can just catch the throwable and return anything I want. I have no idea what to return, so I'm going to do this. And let's see if it works.
I mean, that is the perfect return, right? Just,
I don't know. What's the status? Ask again later. Maybe that should have been the correct answer. Let's see if that works. All right. So again, the first benchmark is going to warm up the configuration and so on and so forth. And then the second one should be quick, and we shouldn't get any errors. We should get some default value. By the way, I'm going to test with a single request if we get 200 with this emoji. Is it called shrug, something like that?
Yeah, I actually have that as a shortcut in my keyboard expander because I use it so often. So
you see?
Not sure what that says about me.
I have failed requests, 0 failed requests. All of them are just, I don't know. Let's test with one. Clear. Works.
There it is.
Let's see if it's 200. As you can see, it is 200. We have the correct response. Does it make sense, Nate?
Yeah, absolutely. I mean, I love the circuit breaker pattern, and thanks to Michael Nygaard for popularizing this back in the day. And it's just, it gives us more control over what's happening, so that we can look at this and say, all right, what's the right response? Is it a default answer? Is it to defer to a secondary or a tertiary service? Because the important thing to remember is when we have these distributed architectures with lots of moving parts, there's more failure points. There's more places where things can go wrong. And so you need to be prepared for that, because the last thing you want to do is have this come back. We've all gone to a website and you see a stack trace. And as a developer, I'm always like, oh, so that's what you're using behind the scenes. Ha ha ha. But that's not a great user experience. And so it's best, it's on us to make sure that when these expected and unexpected things happen, we have a reasonable response, and that we give people either information so they know what to proceed, we can swap in something else, and you can start to make those business decisions that it's okay for this part of the system to be down for 5 minutes or 15 minutes, but if this part of the system's down, we absolutely have to have a backup. There has to be redundancy in place. I've been reading this book about the Apollo 8 program, or the Apollo 8 mission, and part of the whole space program thing. And there was this line about how many parts there are in the Apollo spacecraft, and how NASA loved to talk about there's this many parts, and even at a 99.9%, everything's perfect rate, that still means X number of thousands of parts could fail. And what they didn't necessarily publicize is a lot of those parts were there as backups and redundant backups and backups to the backups to the backups. Because if you're going to throw human beings into space, you don't want to just be like fingers crossed that everything is good. So it's same. Now, obviously, we don't typically have to worry about life criticality, but we certainly need to think about how will our system respond if this thing we rely on isn't working the way we expect.
Yeah, one thing I would like to emphasize is that what do you return as fallback? What you return as fallback is most probably almost always a business decision. So imagine if the recommendation service for recommended books is down, that's pretty much safe to return some hard-coded books. But if you are dealing with weather forecast, is a good fallback a forecast from 3 minutes ago? I have no idea. Who's the client? Is that a kite surfer? Probably fine. Is that the pilot who is going to land in here? Probably I should ask business if that's the right window, right? So you always be sure to ask the business if that's the correct fallback that we are using.
Yeah, that's a fantastic point, Jakub, is that this is really a business decision, and it's on us to help communicate, discuss with our business partners what's the right way to respond in these situations.
Yeah. So one question would be, how does the circuit breaker know when to close and open the circuit? Like when it opens, when it closes, like things like that. So it all goes down, of course, to the configuration. But one thing I didn't make clear is that circuit breaker has 3 states. Closed, when everything is fine and you call the external service, and then you calculate some ratio. If the threshold is exceeded, then you open the circuit and you return the error immediately or the fallback method. But then every now and then you go to the half open state when you test the connection. So again, you have a configuration, which means, hey, in this sliding window, how many requests were failures, how many requests were successful, and depending on the answer, I'm going to go back to the open state or maybe to the closed state. So how does it work in practice when it comes to configuration? Let's take a look in here. Too many windows. All right. So you can have a configuration per circuit breaker you have, or you maybe want to have a global configuration for the entire service. Let's go with the second option because it's just quicker for the demo, of course. So you create a bean. It's going to be customizer. Oops. Customizer. And then it's a resilience for J. So I'm going to use resilience for J. Circuit breaker factory. Default customizer. If I do a typo, sorry in advance. I do a lot of typos nowadays. I don't know what's going on, by the way.
No, that's just for teaching purposes. That's why you do that.
Probably, yes. So then I want to return factory and say, hey, factory, configure default with this ID, and then new resilience for J config builder. Oops, I don't want this. With this ID, and I want to configure circuit breaker config. And now what? I want to use some custom thing and then just build it. But maybe I want to change something, like I want to create the sliding window size. So how many requests are taken into account? Or maybe I want to use something different, like a failure rate. It's going to be, let's say, 50%. Or maybe I want to use permitted numbers of calls in half open state. Again, it might be, for instance, 20. So if I do 20 in here in half open state, it means I have more or less the design we showed beforehand, like the sliding window is 20. If I have more than 50%, hey, I should open the circuit, which means I don't call the external service. It's a little bit counterintuitive. When the circuit is open, you don't call the external service. When it's closed, you actually call the external service. And then in half open, again, the permitted number of calls is 20. And then you calculate the threshold. If it meets your needs, then you go back to the closed state or maybe to the open state. So it's all configurable. I strongly encourage you to read the manual before using Spring Cloud Circuit Breaker. It's a great tool, and the documentation is tremendous. Like everything you need to know about that is there. There are, of course, implementations, as we already mentioned, related to Resilience4j, Spring Retry, Hystrix, and something else that I forgot. All right. That will be it when it comes to the demo.
Awesome.
Any questions, Nate, about this?
Yeah, that's fantastic. I'm a huge fan of Circuit Breaker. I think it's one of those things that we architecturally owe it to our customers to make sure that these kinds of things are in place. And I'm obviously a fan of the Spring Cloud Circuit Breaker just because it gives us that nice abstraction layer and lets us swap out implementation. I mean, we've already seen that. I mean, for a long time, Hystrix was the answer, and then, well, we're not going to support that so much anymore. So to be able to swap that in and out to me is huge to have that layer of indirection. So
cool.
Well, I think that takes us to the end of our prepared material here. So I think Bob and Ivan.
You ask and ye shall receive. And I even had a wardrobe change.
Oh my God, a wardrobe change. I should have changed wardrobe too.
I'm like Cher or
oh my God,
Elton John.
I hope there wasn't a wardrobe malfunction.
No, I'm not like Janet Jackson. That's a little different.
That's right. That's right. You're a professional.
That's right. So thank you so much, gentlemen. That was incredible. And a reminder to everyone, this whole episode will be put up on our Tanzu YouTube page. So obviously give us a day or so for it to get uploaded and whatnot. But all this will be uploaded onto our Tanzu YouTube page. I've got some coworkers asking for some snacky and some water. So with that, we're going to have Ivan ask a couple questions. Now, to be clear, tomorrow is going to be all interactive, all Q&A. So we're going to start at 9, and we're going to have 40 minutes allotted to any Q&As that you attendees might have for Jakub and Nate. Ivan, who is my friend and a wonderful person, is going to be curating, and so he will be, just like today, on the Q&A responses, and so he will be pulling up whatever questions to ask to Nate and Jakub. So you have to come back tomorrow, use the exact same Zoom link at 9 a.m. Pacific, and have your questions. So tonight, think about it, let it marinate, let it stew in there, all the fun stuff that you learned, ruminate, and make sure that you write them down, because tomorrow, who knows what's happening tomorrow. So write down your questions, and then come back at 9 a.m. Pacific time to the exact same Zoom link, and we will have the Q&A run by Ivan. And so this is going to be Ivan, excuse me. This is going to be a bit of a teaser. So Ivan, you have a couple questions for these fine gentles?
Yes, we actually have a ton of great questions. I just want to applaud. Since it's virtual, there's no chance to applaud Nate and Jakub.
Thank you.
Yeah, you guys did a great job.
Awesome.
So the first question that was asked was actually pretty good. It's what about the idea of 15-factor apps? You guys talked about 12-factor. What about a 15-factor app that adds security, telemetry, and API first?
But it goes to 15. Yeah, so there's all sorts of different ways to slice and dice, to be clear. And I think those are very good things to consider. Security is obviously a very important thing for us to keep in mind these days, and even the factors that Jakub and I talked about in terms of should that be a microservice. We've never intended any of these to be the totality, that this is it. So I would think the 12 factors I'd look at the same way, that it is not necessarily the only things we consider, but it's definitely kind of the big pieces of that equation. We didn't really get a chance to talk about sort of observability and monitoring and things like that. That kind of gets into some of the more the SRE things. You can talk about the golden signals and things like that. So there's an awful lot more to it. But we only have 2 hours. We don't want to keep you here all day. We could. I'm sure at Spring One we'll talk a lot more about these things as well. But no, that's a good question. I've never intended any of these heuristics that we use to be, the complete sphere. There's always other things that we have to consider, and you have to consider your own situation as well. What matters to you, and what's going on in your environments.
Nothing more to add from my side.
Sorry,
So
Jakub.
we have
I second that. Yeah.
few more minutes.
You're right, Nate, by the way.
Cheers. I'll Venmo you that later today.
Thank you guys for answering. So since we just have a couple of minutes left, somebody asked if you guys could explain color code a little bit more. Like, what is color coding?
So like the color codes that we used for the event storming.
Yes, correct.
Yeah. Jakub,
I can take it.
Yeah, you're an expert on this.
So during the event storming session, depending on the purpose of the session, you will have different elements to be represented on the board. Like you possibly start with domain events, and you want domain events to be represented in one color. Like most commonly is done in orange, I guess. As I said, I'm a little bit colorblind, but I think it's orange. That's the most.
It also
common
depends on what sticky notes you have access to.
Yeah, come on, correct. And then, for instance, you have elements which represents like queries to your system, like read models. They are represented in green. And then you have policies, process managers. These are purple. You have commands like do something, like attach this file or remove this attachment. This is an indicator of something to be done, not that was already done. So it's a command. That's a blue node. Then you have some rules if you go down there with design level event storming. So you have invariants, the rules that always have to be true in your system. You most possibly put them as my memory. I think my memory serves me well, but it's I use always yellow nodes for that. And so feel free to expand this legend to your needs. So if you need something more, like you need a hotspot, which is red, you need like some metric, you can create your own color. It's not a closed technique.
Yeah.
Even Alberto Brondolini in his book, the creator of the technique, writes that, hey, if you want to use something different because at your organization you need something different, feel free to expand, feel free to experiment, feel free to add colors and actions that you want to be represented on the board. So this is it when it comes to colors during event session.
Yeah, I'd say as long as you've got a key or a glossary, you're in a good place.
Correct.
So it's a good way to visually group and immediately know what's going on.
Yeah, thanks for summarizing this in one sentence. Yeah, that was better than my answer.
So let's see, we have just 4 minutes left. Could you guys elaborate a little bit more on bounded context?
Yeah, I think
in 4 minutes.
Well, I mean, the shortest answer I can give is it's within this bucket. This term means the same thing. And once you cross outside of that, that term means something else. So again, policy means something different to the billing team than it does to the underwriting team than it does to the claims team.
Yeah. What is account, by the way, Nate? What is account? How would you describe account?
Right. I mean, it's the same thing. I mean, I've realized this fairly early in my career. I'd done some paper mock-up sort of UI, and I had a cancel button, and I walked one of my customers through a scenario and said, okay, now you realize you made a mistake. You need to like undo. What do you do? thinking she'd hit the cancel button, proverbially on my paper mock-up, and she wouldn't do it. And so I kind of let her ruminate a little bit. And I said, well, what do you think would happen if you press cancel? And she said, oh, I'd never press that. And I said, really, why not? She said, well, that would cancel their account, because she worked in billing, and in billing, cancel means you're a deadbeat, you haven't paid your bill, we don't cover you anymore. I'm like, oh, guess I can't use that term. And so you find that stuff in event storming too, where you think about it one way and their business partner's like, no, that is not the right language. It's this instead, or we think about it that way. And you're like, oh, okay, mind blown.
Yeah, account in billings context, which is a bounded context, means one thing, right? But if you take the context out of it, like then there is nothing. Like that's an account, and then again you can put it in a different context. Let's say emails, right? And then you know what the account is, and so on and so forth. So depending on the context, a term has a consistent meaning inside of the context. This is a bounded context, but we don't have time to elaborate more. I encourage you to read Domain-Driven Design book by Eric Evans. The concept is explained. I think that's the best source to read about bounded context. It's out there. Or maybe Alberto's book, to introduce event storming. He also talks about bounded context.
Awesome.
So we're almost out of time, but we have a bunch of really good questions that definitely need a lot more time. Like, how do you do the circuit breaker pattern in a serverless environment?
And luckily, we have tomorrow to get into some of these questions, my friend.
Tomorrow, I love you tomorrow. You're only a day away. All right, so tomorrow we will see you back again, same Zoom link. Thank you so much to our, I want to call them panelists because we're on Zoom, but thank you so much to Nate and Jakub, our presenters, Yvonne, our Q&A extraordinaire. We've got people behind the scenes, Jamie and Tasha and Ron. They're all working hard to make this thing happen for everybody. So thank you so much, everybody. Thank you, attendees, for coming. Remember, this will be up on YouTube under the Tanzu. Just search Tanzu page for YouTube, VMware Tanzu. And we'll see you tomorrow, 9 a.m. Pacific, same Zoom link. Bring your questions. It's going to be exciting, and we'll have a great Q&A session. Thanks, everybody.